All right, I think we've got everybody online. Welcome. Thanks for taking the time out of your day to join us. It's a short week, so I think everybody's schedules are a little bit out of whack, like mine, but thanks for taking the time to join us. My name is Tanner Watt. I'm a municipal program specialist with local authority services, and I'm joined today by Doug Leach, who's the Ontario Region Engineer with Armtec, who's the supplier of our Bridge-in-a-Box program. So we're going to be taking a look at that program today. These are a really great fit for a lot of our municipalities, and Doug is going to go through what they are, how they work, and what the appropriate use cases would be. This is part of our municipal group buying program. We launched it about a year and a half ago to help municipalities out with the products and services that they buy every day to keep their communities running. So our goals for this program are to help reduce costs through aggregate purchasing and also to help save time through procurement. So rather than each municipality needing to do the same RFP 400 times, we do it once and everybody can take advantage of that. A couple housekeeping notes. We are recording this webinar and we'll be posting it on our website and sending out a link to anybody who registered. We'll also send out a copy of the slide deck with the email. For the question and answer, which we'll do that after Doug's presentation, we're going to use the Q&A feature built into Zoom. So at the bottom of your screen, you should see a Q&A button. Click on that and feel free to type in questions at any time throughout the presentation. Once Doug finishes up his talk, then we'll go through those and answer those live. And of course, you're welcome to add any more questions at that time. So with that, I will hand it off to Doug.
Good. Thanks very much, Tanner. You can hear me okay?
Yep.
Great. Thanks, Tanner. To all who have taken time and joined us today to hear about Armtec's prefabricated modular bridge-in-a-box. As Tanner mentioned, I'm Doug Leach, Ontario Region Engineer for Armtec, and I'll spend the next half hour explaining the features of this product and hopefully where it may fit into your bridging program. First of all, what is Bridge-in-a-Box? It's a pre-engineered bridge composed of manufactured modular sections which are quickly and easily bolted together on site. In most cases, for prepared foundations, the bridge deck and the girders can be set together in one day. The bridge-in-a-box is suitable for remote sites, resource roads, and rural roads with low traffic loads. The Canadian Highway Bridge Design Code defines these low volume roads, and Bridge-in-a-Box is designed specifically to meet this particular market. The Armtec Bridge is available with a single or double lane with widths to 8.4 meters and lengths up to 24.3 meters. 24.3 meters, that's an 80-foot long bridge. They're designed to the Ontario Highway Bridge Code as CL625 truckload. That's the normal truck you see rolling down the highway. And also to what's called L100. L100 is a sort of an idealistically made up truck that they use to calculate the weight, but it's sort of similar to logging trucks or heavy permitted vehicles that may be required on the roads. So these bridges are designed to handle that kind of traffic. Low volume roads are defined mainly by the traffic count. The bridges on low volume roads are all classified under CHBDC as Class C and Class D, which have restrictions placed on the bridge as well. The maximum traffic is defined as either 400 cars per day at 50 kilometers per hour or 100 cars driving at 80 kilometers per hour. That's the definition of a low volume road. The bridges themselves on these roads cannot exceed 8.5 meters, and the deck can't be higher than 5 meters above the ground or the water. The idea of the low volume road bridge is this: little traffic at low speeds and a low deck have a low probability of occupant crashes. and if there is a crash, the vehicle will not fall far or into deep water. With the restraints defined, it's easier to understand the design features of the modular component structure. Guardrails are most often Thri-beam or the standard W guardrail. The connections are not crash tested and the posts may break or bend with some give. The intention being slow the vehicle from what should already be a slow speed. Low-rise timber wheel guards can also be used if the owner wants to use those. The decking options, you can put either gravel, concrete, asphalt, or timber running planks. The travel surface is placed on the decking with corrugated metal planks shown here at the bottom left, which span the main girders. The corrugations provide stiffness and strength, and the valleys are always filled with select material before the travel surface is brought to the final grade. The deck plank is generally galvanized, but the remaining components can be painted, galvanized, or supplied in weathering steel. Typically, the pricing hierarchy is paint, weathering steel, and galvanized in terms of low cost to higher cost. The main bridge components are shown here and include the main support girders, the cross joining diaphragm, which is connected to the girders by the diaphragm splice. Side and end dams are connected to the bridge plank deck that's shown there up in the left side, and the post block is pre-connected to the main girders with the guardrail then bolted to the block. So that basically shows you the components that make up the bridge, and then you'll be able to see how they sort of arrive on site in that condition. Excuse me. Installation begins with the shipment of the main girders, complete with factory bolted diaphragms. You can see those on the left. For structures up to 60 feet in length, the girders are made as a single component. When structures get longer than 60 feet in length, right up to 80, they must be made in two sections and spliced together in the field. The girders are stacked for easy removal and placement by the site crane. Depending on the bridge size, modules may be shipped with or without the deck pre-assembled to the girders. Either way, the modules are loaded at the plant as a last on site, first off kind of loading procedure, so that the offloading matches the installation sequence. You take it off, basically take it off the bridge. The first piece that then goes onto the bridge is the first one that comes off the truck, and you can literally place it if need be. The bridge plank deck arrives assembled with the end dams in place. Factory welded lugs are shown here. They're included as well, so you can safely lift and place the modules. The weight of the modules have been already pre-sent to the assembler, so he's very knowledgeable in how much they weigh, so he can get his most cost-effective selection of crane size in place to be able to use. Here it's easy to see how a fully prepared contractor can assemble the complete deck in one day on prepared abutments. In this job, the full girder and deck was factory supplied in two pieces. The trucks arrived, he's lifted it off the truck and literally going to set it right directly onto the abutments now. For multi-panel decks, plank sections are set into place and spliced together through pre-drilled factory welded side plates. On the left, you can see the connection holes, and the picture on the right illustrates the deck corrugation. The wood on the deck is dunnage that was used to support the deck pieces during delivery. A lifting lug is visible as well. So that shows you the depth of the corrugation that's on the deck itself. That particular corrugation depth is what's filled in first, and then the final driving layer is placed on top of that. The bridge sections are joined by bolted connections referred to as diaphragm splices, shown on the left. In the upper right picture, and also in the upper right picture, on the bottom right, the guardrail blocks are factory attached to the outside girders, ready for the posts. So you can see all of that material is on the deck when it arrives at the site. So it's basically bolt the pieces together. The post block, the post and rail are all factory drilled for easy bolting in the field. The contractor simply bolts the posts to the steel block. The bridge assembly is completed with the placement of the selected deck area. The final surface may be gravel, concrete, or asphalt. For gravel running surface, the deck plank corrugations are first filled with free draining gravel, followed by a non-woven geotextile, and lastly, a well-compacted select gravel surface is put in place. Abutments and foundations are usually done through the owner's consultant working in collaboration with Armtec in order to match the bridge site's condition. Common foundation supports include steel piles, spread footings, mechanically stabilized earth, or bin type retaining walls. Pipe piling systems, including pile caps and back walls, designed by the consultant and installed by the contractor, are very common. Armtec supplied pre-drilled bearing plates and flexible elastomeric seating pads to marry the deck and the abutment. You can see these here. On the left, you can see the pipe piles and the pile cap. Those are typically designed by the owner's consultant so that they're sitting ready. We usually are in conversations with the consultant in order to make sure everything fits together at the right time. And our part begins where the pad and the bearing plate are connected to the top of the piles. In this application, the designer has specified a precast back wall. You can see that wide flange beam pilings and capping, a little different than the round piling. These are wide flange beam cappings. The bearing plate and elastomeric pad complete the foundation to the bridge connection. So again, you can see how those are connected to the bottom girders of the bridge. Armtec manufacture what's called a bin wall. That's often used in combination with a concrete bearing pad as a good low-cost alternative where deep pile driving is difficult or expensive. The bin wall provides flexibility. It's easy to set the elevation of the bridge and also the strength for the bearing pad. Bin wall abutments, they're excellent choices for remote sites and fast abutment placement. The bins are delivered to the site as easily assembled components, which 4 to 5 man crews can construct in 2 or 3 days with no need for heavy equipment and cranes. So in very, very remote sites, these particular bin walls, they arrive again in components. They're put together. Doesn't take big cranes. You can do them with small equipment, so they're fairly easy to assemble. Bin walls are also used for wing walls, some with front ice shields. The bottom left-hand corner shows a structure that's got an ice shield on the face. And in many cases, Armtec assists with the bin wall design. All we would do all that's required by Armtec is some very general information, such as the bridge span, the live load, the roadway width, and the bridge dead load. And we can put the abutments using bin walls together as part of the package. Bin wall are also manufactured. They're manufactured in 16-inch high increments. You can see in the top picture there, the sections, those are all 16 inches in height and may reach as high as 10 to 12 meters. They're excellent alternatives for higher than 5-meter level bridges, which are these ones here, standard girders or girder bridges, and also for other prefabricated structures. So with the foundation and abutment work complete, the bridge is lowered into place, and once it's centered, aligned at its correct elevation, the girders are then welded to the bearing plate. This is really the only part that welding is involved with on the site. Everything else is bolted together. So once everything's set correctly, the girder is welding to the bearing plate. And at the front there, you can see the bolts that go through the bearing plate and down into the flanges to hold the bridge to the foundation. Now, there's actually at the other end of the bridge, there's the connection is the same, but this time there's a special slotted hole that's put into the bearing plate. And the slotted hole basically allows for expansion and contraction of the rigid steel deck. So if it's able to move slightly one way or the other as it expands or contract according to the weather. The other end is pinned, as I showed you before, and the slotted hole allows it to move around a bit. This is what a typical set of Armtec bridge plate drawings look like. It includes the girder details, assembly instructions, lifting instructions, weights, bolting connections. This is what one gets as part of the package to put the whole bridge together. To ensure a good on-site fit, the bridge is fully shop assembled, bolted, fitted, checked, matched in the shop. Not until all the modules fit correctly is it disassembled and then placed on the trucks for shipment to the site. So we basically ensure that it goes together in the factory and it'll go together on the site, because there's nothing worse than somebody getting there and it doesn't fit. So that in itself is extremely cost effective. On this particular structure, this one the checks are being made on timber plank travel surface, which bolted to the deck. You can see this is half a bridge here. This is one traveling lane, guardrails on one side, the posts, the girders, and it will be shipped to the site like that without the guardrails on it. In summary, the Bridge-in-a-Box is a pre-designed, prefabricated composite steel bridge that's designed for low volume roads. They're rated to CSBC truck loadings for fast and easy assembly, and easy to install for remote sites. They're great for low traffic roads, rural and forestry roads, and available in single and double lane structures up to 80 feet in length. Just to finish up here, we'll just do a little bit of a tour of some of our projects. Here at Kinsby, Saskatchewan, this is southwest of Regina. It's a timber wheel guards that have been used on a gravel deck. The structure is 8.5 meters wide and 15.6 meters long. That's a 60-foot long structure. It's being lowered. That 60-foot length is the maximum that we can do in one girder. If they get up into 80-foot girders, which is the longest, you end up having to splice 2 girders together. So 60-foot max, and anything longer than that would require 2 girders. This is a 60-foot long structure with 2 lanes. Armtec bin walls and wing walls have been used on this structure. This is also in Saskatchewan. Installed in southwest Manitoba near the North Dakota border, this 7.3 meter wide by 15.2 meter long bridge replaced an old timber pile single lane wooden deck structure. It had a low traffic count, so they used a single W-beam guardrail and selected the gravel surface. You can see here, there's variations that you can use depending on what your bridge consultant might feel comfortable with. This one uses precast concrete wing walls that are held in place by pile-driven W-beams. In Maple Ridge, British Columbia, this is a dual lane, 11-foot wide lane structure that was used to replace an existing structure. Interesting, this one left the concrete abutments in place from the original bridge, and they reset the new bridge on top of that. In the bottom right, you can see they're placing 1/2 of the deck onto the existing concrete abutments that are there. These are a couple of structures just to kind of show what it is. And with that, I'd be more than happy to take any questions that you may have. Thank you very much.
All right, thanks very much, Doug, for that. We've got a couple of questions ready to go, but if anybody else on the line has anything they'd like to ask, please type it into the Q&A box coming up. One thing I would like to let everybody know before we start is we do have another webinar scheduled for 2 weeks from today to talk about our new aggregates offering, which would probably be relevant for a lot of the people on the line for this one. If that is of interest, check out the events page on our website for more information and for a registration link for that one. So the first question that came in, if a farm tractor is pulling a trailer of some sort, like a combine or a wagon, and the trailer hits the guardrails, will the guardrails in the bridge survive, or are we looking at full replacement?
That's a good question. The guardrails probably will be bent, may break the posts off. It won't damage the bridge. The bridge will be fine. So it would basically end up as a guardrail replacement. Yeah, that would be it. And that's not a big job, as you could see. It would take just to unbolt the post itself if that's all that's damaged, or even perhaps the connection point. But it wouldn't hurt the decking or the bridge itself, no.
Okay. So next one is, what's the life rating of these types of bridges compared to a conventional bridge? How long will they last?
Okay, again, a very good question. The code itself actually requires the bridges to have a 75-year life expectancy, okay? There are actually, as I mentioned, 3 possible coatings, the paint, the galvanizing, and the weathering steel. Weathering steel, of course, has a special alloy that in and of itself, it sort of is meant to rust a bit and protect itself. Galvanizing itself is also standard 75-year life. The thought behind this is that in most of these roads, because the traffic is so low, they rarely have a bunch of salt on them. So in that particular situation, the Ontario government basically says, okay, these have a 75-year life because of the coating itself, the galvanizing and the weathering steel. So they have to be designed to they're expected to have a 75-year life, and we put the galvanizing and weathering steel together to be able to do that. Yes.
Okay, thank you. Next question, pretty simple. Costing, please. So how do you go about getting costing for a bridge project?
Okay, good. Thanks a lot. The easiest way to get the costing would be there are some it's to be able to send a request into myself and or Mr. Sam Mitra, whose I think name is connected with the bridge plate, or excuse me, connected with this particular program. And we'll be able to look at that and be able to put your price together. Maybe takes 2 or 3 days and give you a budget kind of price for something like that. The one thing that we're finding now is because of the situation, the steel prices are sort of going crazy, up and down and all over the place. So what we would give you budget wise would be the best that we had at the time, but I would just merely say that the steel costs have fluctuated crazily this year. So but yes, we could give you a price. Typically it's worked out as a cost per square meter of deck. That's sort of a simple way of doing it anyway. But a price, it takes about a week for us to put together a price. Just give us the size, length, and a little bit of detail for it.
Okay, thanks. Next up, is there any option to have 2 bridges in series?
I'm gathering that he's talking about a middle pier, or so one bridge and then another. There's no reason, if that's the question, there's no reason that couldn't be done. The code itself basically does not allow these bridges to be longer than 80 feet. That's and the width that I spoke of, 8.4 meters, but there's no reason why you couldn't put a single pier in the middle of 2 in series.
Okay. Next, what are the maintenance requirements and how do they differ from concrete structures?
There's very little maintenance at all on these particular structures. Once they're put together, there may be some minor, perhaps painting of paint that might not be on them, or repair of guardrails or anything to that effect that might get bent. But outside of that, there's really not too much. You just sort of check underneath and make sure everything's okay, but very, very little maintenance. That in the case of the deck itself, in the corrugations, I didn't mention this earlier, but I think I'll bring it up now. If you put the most common one that's used, of course, is the gravel decking. If you're going to use an asphalt deck, the corrugations itself are typically filled with concrete first before the final asphalt's put on. Asphalt itself is very difficult to get compacted and stay into the corrugation. And if you use asphalt for the whole depth of that corrugation, it has a rippling effect on the final layer asphalt. So in that case, asphalt surface, the corrugation is concrete, and the last deck is asphalt. That may or may not be a little bit of a maintenance situation in asphalt. In the case of concrete, I'll just mention this as well. The actual corrugation has little studs that come up in the bottom, or studs are welded in the bottom for the concrete to adhere to in the corrugation depth.
Okay, thanks. So next one is what are the advantages of bridge-in-a-box? Why would somebody choose a bridge-in-a-box versus a conventional bridge design?
I guess the big reason, these are not meant to compete necessarily with conventional bridges. They're designed more, well, they are designed for as a as has been mentioned, low volume roads. The benefits are basically bringing the structure to the site pre-assembled, and you can build them very quickly. There's not a lot of work involved other than bolting it together. It's like a big mechano set. So you lift it off the truck, put it on the girders, and they're very simple to assemble. That's the biggest saving of anything. And you can get them cost wise. They're very inexpensive as well. If you only want one lane, for instance, maybe that's what you want on low volume road. The second lane, that's always debatable. The cost typically runs, as I mentioned, on a per square meter deck. So the cost of a single lane bridge may be only 60% of, say, a double lane bridge. They're almost a half and half kind of situation. So that's probably the biggest cost saving and reasons for using them rather than a conventional bridge.
Okay. We've got another question, a little bit more about the program, so I can probably take this one. So the question is, who has to purchase the structure under this program? Can the municipality specify the product and the contractor work with the supplier to make sure the product works with the specifications issued by the consultant while still accessing the same pricing as the municipality would receive through the LAS program? In my mind, this is something that would not be a particularly big issue to get set up. If this is something you would like to do, send me an email when you're ready to get started, and we'll make sure that everything is set up properly to make sure that however you are sourcing that and setting it up, we can make sure that you're still able to have the pricing available through the LAS program. Okay. All right, so I'm not seeing any other open questions, so we'll hang around for a few more minutes to see if any others show up. Not seeing any. Thanks everybody for taking the time to join us. Hopefully we'll see you again in a couple of weeks where we'll be talking about the new aggregates offering. We do have all of our formerly recorded webinars up on our website. You can find that in the webinars and presentation section. We've got maybe 20 or more of them up there that cover a very wide range of topics. And as always, if you have any questions about the program, feel free to reach out to me directly. So seeing no other questions coming in, I think we'll wrap it up there. Thank you very much, Doug, for your presentation. Thanks everybody for joining us, and we'll see you again next time.
Thank you.